Hi everyone, so in this project we are going to learn how to get information from our physical world. In this project we'll be playing with the temperature sensor, which is this black one right here. As its name suggests, temperature sensor detects the temperature around it. So in this project we will also be using 3 LED lights. So I have red, green, and yellow over here. These LED lights will tell us the relative temperature change. So how are we going to get a big temperature change? Well, easy, with your finger. The room temperature is around 25 or 26 degrees Celsius, but our finger can reach about 29 or 30 degrees Celsius. So I'm going to do a quick demo over here. I'm going to turn off the lights so you can see the LED lights clearly over here. So lights off. So I'm going to put my finger right here. Hopefully it's going to heat up pretty soon. Alright, so you can see that the yellow LED light is blinking, and then there goes the green one. Hopefully I can get the red one. See if my finger temperature is over 28, 29 actually. Alright, it's blinking. So this is basically what this project is going to show you. It's a really simple one, and it's just showing how to play with a temperature sensor.
Before we start building our project, I want to introduce the idea of analog. One of the main differences between the real world and the digital world, such as computers, is that most of the stuffs in the real world are analog, meaning that they are not just on and off, like a switch being on or off. Take temperature, for example. Your body temperature could be 37 degrees Celsius, boiling water can reach up to 100 degrees Celsius. You rant about the weather being hot when it's 30 degrees Celsius, but start shivering at 10. So temperature has more values than just on and off. And this is an example of analog. Alright, now let's look at the new components we're going to use in this project, the temperature sensor. If you look at the top of your temperature sensor, you can see that there's one side that is flat and the other side that is curved. Alright, let's look at the temperature sensor by turning it so that the flat side is facing you. As you can see, there are 3 pins under here. The left one is where the 5 volts comes in. The rightmost pin is where you connect the ground. Right now, the tricky part is the middle, which we call it the analog voltage output, and this is where you connect it to the analog pin. The analog pins are located at a different section from the digital pins. I will give you a quick demonstration when we're building the circuit. Alright, next let's look at the schematic view of this project. Notice that there are 3 LEDs right here, 1, 2, and 3. The upside down triangle indicates the LED light, and the 2 small arrows right here just means that there's light emitting from it. These squiggly lines over here, this 1, 2, 3, these are resistors. The most important part of this diagram is I want you to take a look at the temperature sensor over here. Notice that, see how it connects there, it connects to 5 volts over here, and it connects to ground. It also has a pin that connects to A0, which is a pin you will find on the left side of your Arduino board. So now you have the big picture down, let's move on to actually building the circuit.
Alright, so right here I have all the ingredients right here. On the left I have some jumper cables. On the right I have 3 LED lights, so red, green, and yellow. 3 resistors, each of them is 1000 ohm. The temperature sensor, so this is a new component, the Arduino board, and the breadboard. So let's look at this temperature sensor. If you hold it this way, you can see that this side, that there's one side that is flat and the other side that is curved. So when we were talking about the left side being the pin where you connect it to the 5 volts, make sure that you're holding the temperature sensor so that the flat side is facing toward you. So this is where the 5 volts comes in, and on the right hand side this is where you connect it to ground. Okay, so remember that you have to connect to the right side, because if you flip it the other way and connect it wrong, the temperature sensor might start to heat up and might burn your hand. So just be careful about this. So the first thing we want to do is to connect power, to give power to this breadboard. So I'm going to connect it to ground, to negative, and 5 volts to positive. Okay, so once it has power, the next thing I want to do is I want these LED lights to read signals from these digital pins. So in this case, I want it to be 2 for yellow, 3 for green, and 4 for red. So I'm going to start with the yellow one. In this case, I'm going to make sure that the longer end of this pin, which is the positive, will be on the on the upper side. Okay. Next thing you want to do, you have to connect this to power. But then your power or your signal has to come from pin 2. So what we're going to do is going to plug in pin 2, which is 0, 1, 2, the third pin over here, to positive. Then you have to connect this back to ground. You can also use a jumper cable and then connect it to a resistor, but an easy way out would be to use a resistor. So what you do is this negative, so you plug it right here and then connect it to ground. Alright, and the next thing, you do the same thing for green and red. Alright, so as a quick review, I want the pin number 2 connected to the yellow, 3 for green, and 4 for red. Once you have all the LED lights connected, the next thing is to connect the temperature sensor. So in this case, we want the flat sides to face this way. Alright, so we will connect the 5 volts on the top and then the ground on the bottom. So there are 3 pins, so you just plug them like this. Alright, so I want the top end, which is the leftmost end when we were talking about early, connected to 5 volts, so like this. Alright, let's make sure it's connected. And then the other one to the negative. Okay, now the most important part is the middle section. In this middle section, you wanted to connect with an analog. We want to read the signal from this. And if you look at your Arduino board closely, you can see that on the right side it says digital right here, and on the left side it says analog. So we want this middle pin right here, we want to read the values that are sent from this temperature sensor to this A0 right here, or A0 over here. So I'm going to connect a wire from here, the middle, all the way to A0. Alright, so that's what your circuit's going to look like. The next step is to start coding, and then you're going to upload your code. Once you upload your code, it should start working.
Alright, so open up your Arduino IDE. The first thing we want to do is to include the 2 functions. So the first one is void setup, and the next one is void loop. Remember that these are curly braces, while this is just parentheses. Alright, so inside void setup, we want to put all the configurations in it. So we want to tell Arduino that for pin number 2, I want it to be an output. Same thing goes for pin 3 and pin 4. Right, let's put a comment beside here so we know which LED lights we're talking about. So yellow, green, and last one is red. A quick reminder, 2 backslashes right here meant that whatever we write behind here are comments, so the compiler doesn't read them. It's just for our own benefit. We can just read it, so the compiler ignores it. Alright, so once we're done with the configuration, we move on to the loop. So the first thing we want to do in here is to read the value from the temperature sensor. So I'm going to write int sensor value equals to analog read. Remember, we plug it into pin A0, so we're reading the values from A0. Alright, there are 2 things I want to talk about here. The first one is the analog read. Analog read works just like digital read, except that it's analog this time, so all we're doing is to change the word digital into analog. We then store it into a variable called the sensor value, and this variable stores integer value. So int stands for integer. Integers are numbers such as 1, 10, or 50, or -10. Basically any numbers that do not contain decimal points. Okay. Next, I want to include these two mathematical expressions. So what it's doing right here is once we read in the sensor value over here, we divide it by 1024, multiply the entire thing by 5, and we store this into a variable called voltage. We then use this voltage deducted by 0.5 and multiply the whole thing by 100. Okay, this is an equal sign. And we store this value inside temperature. So what these two are doing is basically to change the sensor value into temperature, something that we can read easily. As for float just meant that numbers that include decimal points. If you're still unclear about these, you can always check out our website. We have a really detailed explanations on integers, floats, and variables, and all these. For right now, basically you can just pause the video and copy these two lines. Alright, so now we have the temperature. We have to tell Arduino what to do with them, right? So the first thing is, let's say that if the temperature is less than 26 degrees Celsius, let's say that we're going to turn off all the lights. So no lights are on. Okay. The code for this is to type if parentheses, and inside this parentheses we're going to put the condition that's going to match. So here we said the temperature is less than 26.0. So whenever the temperature is less than 26, it's going to do whatever it is in these curly braces. Okay, so right now we want to tell it that we don't want any lights to be on. So what we do is digital write. Pin number 2, which is yellow, we want it to be off, which is low. 3, you want it to be low also. Digital write for low. Alright. Next thing we say that, let's say the temperature is between 26 Celsius and let's do 28. 28 Celsius, yellow LED is on. So you see now we have an if up here. The next thing you do is to put an else if. So if whatever this condition is not satisfied, it would move on to the next one. Same thing, you also have to put in a condition after if. So in here you said temperature is greater or equal to 26 and temperature is less than 28. So this is how you're going to express and. We use 2 ampersands. You can get ampersands by hitting Shift 7. So 2 ampersands meant and. So this means that if the temperature is greater or equal to 26 and the temperature is less than 28, do what you want to do inside these curly braces. So the yellow LED light is 2, so I wanted it to go high, but for the rest of them, I don't want them to be on, so they're still low. Okay. You do the same thing for the next one. Let's say that the temperature is between, actually 20 less than 26. Okay. Is greater than, okay. Actually, we want 3 lights, so what we're going to do right here is let's change this to 24. So temperature is 24, temperature 26. So less than 24, 24, and 26. Okay. So let's say if the temperature is between 26 degrees Celsius and 28, yellow and green LEDs are on. So you do the same thing, else if temperature is greater or equal to 26 and temperature is less than 28, you do whatever you write inside these curly braces. So digital array 2 is going to be high. Digital array 3, which is the green LED, will be high. And the last one will be low. Alright, for the very last one. Let's say that for any temperature that is greater than 28 degrees Celsius, all lights are on. For the last one, you also do else if. So temperature that's greater or equal to 28, you want all of them to light up. Alright, so that's all your code. The last step is to verify it. So on the left hand side, you see that there's a check mark over here. This means verify. So click on it. Okay, so we got an error right here. Let's see what's... Okay, so you see right here, when I get an error, it's going to show you which line it is. Let me show you again. Okay, let's look at here. What's wrong? Oh, okay. So it's voltage right here, but I'm spelling it wrong over here. So instead of an A, it's an O. This is just an example if you find a compiling error. See, it says error VALTAGE was not declared in the scope. Alright, so let's verify again. Yay, it's working. So done compiling. The next step is to connect your Arduino board to the USB cable, and then you click upload. Alright, so that's it for the code. Alright, now let's move on to the last step. So you plug this into the USB cable. Next thing you do is you hit upload, and on your Arduino IDE, you can see that these two lights will start blinking. This means it's transferring and receiving data. So once it's done, let's see if it's done. You can start to see if it works. Alright, so the yellow light is blinking. So this is basically the entire project, and if you have any questions, you can always leave it in the comments below. Alright, till then, see you at the next lesson.